Now, once we have done that missing value imputation, the next step is to work on splitting this data into training, test, and validation part. Now, this is really important because if we build the whole model just based on the basically on the whole data, then there is no way that we can validate it. Now, one idea could be that we can just go ahead and create a training set and testing set, which you might have learned in a machine learning course, and create a model on training set and test it on a test it on the testing set. Now, this is also sometimes not a good idea because a lot of times, especially when we play with hyperparameter tunings, we do kind of we do get the results which comes out because of my test data set, and because we start looking at the test set and we start keep on improving the accuracy on my train set, so we kind of start getting a dependency on the test set part. Now, in order to handle that, we come up with a validation set. So what we start saying is that we can split now the data into three parts rather than two parts. And those three parts is going to be like we're gonna create one part for my training set, second part for my cross validation set, and the third part for my testing set. Now, what we're gonna do, we're gonna build and verify our model with the help of these two. Okay, think of cross validation as the test set only. Now, here with the train set, we're gonna build our model, and with the cross validation, we gonna do the hyperparameter tuning and all that, and we'll see that what is the best parameters or metric we're gonna get out of it. And once we get this, then once we have the final model based on the testing of cross validation, then this is completely untouched data. We have not yet used it for anywhere. So we will finally validate our model output with this test set. So that's what we are going to follow in this particular case study. Now, the first question is which is going to come to your mind, that how should split this data. So there are various ways people go for it. Some people take it like 60-20-20. Some people take it like 70-10. So basically 70-10 and 20 depends on you how you want to take up, depends on how much data also you have. What I have taken in this case study is that I have first divided it into 80 and 20, and this 80 again I have divided into 80% and 20%. So which brings us to kind of this sort of data. So this cross validation will be 20% of this 80. So that's what basically how we gonna divide it. So first we gonna write a code which is going to help me to convert into train and test, which is 80-20. And then again on that train data set we will again do a split on 80-20, and that 20 we will give it to cross validation, and 80 we will give to our training data. So that's what the strategy we're going to adopt. So let's see how we have done that. Now, in order to do this, what we have done, you can see that I'm using this train test split function, which is gonna first divide it into 80-20, and this is gonna return me train and test data. Then further to that, we are going to use this train data and again gonna do a split of 20. So we're gonna get the cross validation data now, right? So we got three set of data. One is cross validation, testing data, and training data. So three kind of data what we got. And if you want to look at that how many rows and columns you do have now, you can always look at it by saying shape, and this is going to tell you that in your training data you have some 2124 records, in your test data you do have 665 records, and your validation data have 532 rows. So this is how we can see our data. Now, it's very important point that when we do this splitting, now we always want to see that the data distribution have happened kind of properly. Because we can end up with a lot of issues if we don't have. Imagine I have taken a training set, okay, which, because if you look at it, I have classes from 1 to 9, right? Now there is a possibility that in my training set I have taken all the data for my, let's say, class 1, okay. I have taken all the data of training here, But in my test and cross validation, I have no rows left out because it's a random splitting. So maybe there's a possibility that in my cross validation and test we have no data related to class 1. So there is no way to even go and verify whether my model which is bringing this class 1 is good or not. So now this can be an issue here, right? So we definitely want to make sure that the distribution have happened appropriately, and that's what we're going to look at. Second kind of problem could be that maybe there is a class 7 which may be not at all present in my train set, or very less amount of data have gone here and more data is going in my test and my cross validation. So in this case, we don't have enough data in the train set in that case for that particular class to learn a particular pattern, a good pattern, and give prediction. So that is also a bad strategy. So we may want to look at, if there is any issue, we again will go back to the basics and again kind of to look at again the split and all that properly, so that a distribution happened in the right format. So let's go and see that how we can verify those things up. So in order to do that, what we have done, we have got our training class, testing class, and CV class distribution. And what we have done, we are looking at the classes because that's what is our main worry, that each class should be distributed kind of in a appropriate manner. So what we have done is we are looking at if you look at this code, what this is going to do, it's going to look at that class 1 is in training set, how many times it is coming. So let's say 363 entries of class 1 is happening in my train set. Similarly, class 2 have 289 entries in my training set. So like that, we're gonna get the output for train, test, and cross validation. So this is what we are going to get from here. Now, once we are done with this, now definitely we can I can even look at the test class distribution, I can look at the CV class distribution. But the problem with this approach would be that it will be very difficult to look at the raw output and kind of do a comparison. So what is the best way? As a data scientist, you should be kind of visualizing this. You should look at the graph, right? So if you can put this things into graph, it will be more easy for you to visualize how the distribution is happening. So for doing this, we have plot this particular graph. You can see that this is happening for your train class distribution. So we are drawing the bar plot, and here you can see that for class 1 we do have a good distribution. For class 4 we have a good distribution. For class 7 we do have a very high distribution happening in my training set. For class 8 and class 9 we have very less data coming into this. So let's see what's the case in my other portions as well. But before that, maybe I want to put it in form of percentage here. Like if you look at it, class 7 have the maximum data in my training set. So what I've done, I've written a code to return the percentage of this, that what is the percentage of overall of class 7 in the whole data. So it is almost like 28.672 percent of the data which is coming in the train set for class 7. Similarly, for class 4, we have 20.669, and this was quite easy for us to do that. It's a very simple Python code to get all these values. You can go through it. So this is how you can see this distribution here. Now let's go and check the distribution for my test part. Now for test also, we can see that for class 7 the distribution is high. That means maybe in our original data set itself, my class 7 have huge amount of entries. So even for class 4 we have huge, and for class 8 and class 9 even we have lower number, and you can verify that from this as well. So class 7 we are getting 28.722, and you can see here also in the train set we have almost the same distribution, which looks like, if you compare basically both, this output looks like my random split have happened quite well, right? Let's look at the cross validation, and here also we are getting almost the same output, right? So again, class 7 is very nicely distributed. 8, 9 have very less distribution. Even if you compare for the rest of the class, you can actually check that it's going to be kind of in the same distributed manner. As I said, sometimes it can happen that this distribution is not happening properly or in the same way. In that case, you need to go back and again rework on this. Okay, so don't just blindly start working on any machine learning algorithms. Always keep this in mind. This is a very critical fact, guys, that You have to look at, before you even think of machine learning algorithms, you should always look at your data and see whether, before you plug in your data to machine learning algorithm, everything is in the right format, whether you have cleaned it. All those things are really important as a data scientist for you. Otherwise, you may end up with some messy results. Okay. So we will see the further points related to machine learning now in the next video lecture.